Hello folks, and welcome back. Today's lesson is going to be about exponential and logarithmic equations. Now to start off with, we have a couple of logarithms for you to solve here. How do we combine these logarithms? Log base 3 of x plus log base 3 of m. Remember, addition is the same thing as multiplying on the interior. So log base 3 of x plus log base 3 of m is log base 3 of x times m. What about log base 3 of x minus 5 log base 3 of m? Log base 3 of x minus 5 log base 3 of m. We move the 5 over to the top of the m, so this is m to the 5th. And then subtraction means we divide. So this is the same thing as log base 3 of x over m to the 5. Now let's define an exponential equation, being as that's one of the things today's lesson is about. An exponential equation is an equation with a variable in the exponent. So to be an exponential equation, we need a variable to be inside of the exponent, meaning we need to have some power raised to the x. Now the way we're going to approach these is going to be very similar to the way we can approach this problem. X plus 1 over 5 is equal to 3 over 5. What are the two different ways that we could solve this? Well, the first one, and the one that you all probably thought of, is cross multiplying, right? We look across and we multiply our two groups together and then solve. If we do it that way, we'd end up with 5 times x plus 1 is equal to 5 times 3, or 15. So way 1, cross multiply. When we do that, we get 5x plus 5 is equal to 15. Subtract the x, divide by 5, you get x is equal to 2. Now what about the second way? Well, the second way is we look at this and we say, hold on, our denominators are the same. Our bases of these fractions are the same. They're both 5. So if they have the same denominator, we know that the numerators also have to be the same. If we do it this way, we just say, well, these are both divisible by 5, so that means we know the tops have to be the same. So we say that x plus 1 is equal to 3. And that gets us to our same answer, x is equal to 2. Now this is similar to the ways we can solve an exponential equation. If we have 2x minus 3 is equal to 16, the first method we can use is set them so that they have common bases. Do the same thing as with the like denominators. So method 1 is going to be common bases. We know that we have 2 to the x minus 3, and 16 is a power of 2. Right? 16 is the same thing as saying that's 2 to the 4th power, not to the 3rd power. But 2 times 2 is 4, so that's 2 squared is 4, times 2 is 8, times 2 is 16. And now because these have the same bases, we can say their powers have to be equal. So we say x minus 3 has to be equal to 4, and x is equal to 7. The second method we have is using logarithms. So the second method we have is using logarithms here. If we want, we can take 2 to the x minus 3 is equal to 16. And if we want to get this base to the other side, we can take the logarithm. Right? We take the logarithm, we'd be left with x minus 3 on one side, and we'd have the logarithm on the other side is equal to log base 2 of 16. So all we've done is we've changed our power to a logarithm here. And this is saying 2 raised to what power is 16? Saying 2 raised to the 4th power is 16. So we get x minus 3 is equal to 4, or again, x is equal to 7. Now we have a couple of these that are harder, so let's go ahead and take a look at those. What about something like 16 3 to the x? 16 raised to the 3x, excuse me, is equal to 8. The first thing we want is common bases. So let's bring these down to the most common base we can get, or 2. Right, 16 is 2 to the 4th, so this is 2 to the 4 to the 3x. And 8 is 2 cubed. So we have 2 to the 4 to the 3x is equal to 2 cubed. Or because this is a power raised to a power, that's 2 to the 12x is equal to 2 cubed. Since we have common bases here, we know that each of these is going to, their powers have to be the same. So this will be 12x is equal to 3, or x is equal to 12 over 3, which is the same thing as 1/4. So that's the way you do it if it's more complex. Break it down to its simplest root, whether that's 2, 3, 4, whatever it happens to be. Why don't you all try doing problem 2? We have 27 to the 3x is equal to 81. How do we approach this? Well, we try to get 27 and 81 into their most basic bases. 27 is the same thing as 3 cubed. So we can say this is 3 cubed raised to the 3x, and 81 is 3 to the 4th. So that's equal to 3 to the 4th. That's the same thing as saying we have a power to a power, so we multiply those together. 3 to the 9x is equal to 3 to the 4th. And because these have the same bases, we say 9x must be equal to 4, or x has to be equal to 4 over 9. All right, so that's the basis of finding exponential equations using the common base. How about when we solve by taking the log of both sides? Let's say we have 15 to the 3x is equal to 285. How would we solve this? Well, there's two methods to use depending on which one you're more comfortable with. The first method is going to be taking the log of the base. In other words, we have 15 as the base of our exponent. We could change this by taking the log base 15 and moving it to the other side. Right, this equation is the same thing as 3x is equal to log base 15 of 285. Now we'd have to put this into our calculators. Right? We'd say log base 15 of 285. We change that using our change of base formula, and that would become log of 285 divided by log of 15. Throw that into your calculator, you should find out that 3x is going to be approximately equal to 2.087. Then when you divide by 3, that'll get you to your answer. You find that x is approximately equal to 0.696. So that's the first method we have, is you take the base log from base of the exponent and move it over to the other side. The other thing you can do, the second method, is just taking the log of both sides. What do I mean by this? I mean, take the common log of each side and see where that gets you. If you take the common log, you'd have log of 15 raised to the 3x. And on the other side, you'd have log of 285. So we have log of 15 to the 3x and log of 285. Now we have a power inside of a logarithm here, so we can move that out to the front of the logarithm. We can say 3x times log 15 is equal to log 285. Now log of 15 is just a number, right? This is 3x times log 15, so we can divide that over to the other side. We can say 3x is going to be equal to log of 285 divided by log of 15. And at this point, we just throw it into your calculator. However, the keen eye among you might have also observed that this is the same thing as our change of base formula for log base 15 of 285. Either way, put this into your calculator. You're going to get that this value is approximately equal to 2.087. Same value as last time, so we know x is going to be approximately equal to 0.696. You can use either of these methods to solve for these equations. All right, let's look at some real-world problems and try to solve them using logarithms. We're starting off by saying we have $1,000 in an account. We're putting it into an account that pays 6% annually. We're trying to figure out how long it'll take you to have $1,600 in the account. Now, why don't you start off and see if you can figure out how to set up this equation. So what do we have? We have exponential growth with no compounding. That means we're going to use the form y is equal to a times 1 plus r to the x. Our initial value is 1,000. Our rate is 6%, so this will be 1.06 raised to the x. And we're looking for the time when this is equal to 1,600. From here, we're trying to solve for x. So the first thing we need to do is get this 1,000 over to the other side. We're going to divide that. We're going to end up with 1,600 over 1,000. Or let's cancel out two of those zeros. That's 16 over 10 is going to be equal to 1.06 to the x. From here, we solve using our logarithmic equations. We can either take the log base 10 of each of these, or we can take log of 1 of 6. If we take log of 1 of 6, we'll end up with x on one side, and we'll have log base 106 of 16 over 10. That value will come out to be approximately log of 16 divided by 10, and that's going to be divided by log of 1.06 using our change of base formula. Put that in, you'll find out that you'll have about $1,600 in your account in 8.07 years. It's not a lot of time to make those, or a fair amount of time to make those $600. Let's look at another word problem. We have a car that costs $20,000. It depreciates at 12% a year. We're trying to figure out when it'll be worth $8,000. We're depreciating and it's not compounding. See if you can figure out the equation for this. If it's depreciating and not compounding, we're going to use y is equal to a times 1 minus r to the x. Our initial value was 20,000. Our rate was 12%, so this is 1 minus 12%, or 0.88 to the x. And we're trying to figure out when this will be worth 8,000. Again, we're trying to solve for x, so we first need to get as much as we can over to the other side, or divide by 20,000. We get 8,000 over 20,000, or 8 over 20, which again can be reduced to, let's see, both of those are divisible by 4. That would be 2 over 5 is equal to 0.88 to the x. Again, you're just going to take the logarithm base 0.88 to get this x into, or out of the denominator, out of the exponent. You'll get x is equal to log of 0.88 of 2 to the 5th. So x is equal to log base 0.88 of 2 over 5. Put that into your calculators. Remember to use your change of base, so it's going to be log of the inside divided by log of the base, or log of 2/5 divided by log of 0.88. That'll get you to a value of 7.168 So the car will be worth $8,000 in roughly 7.168 years. And that is it for exponential equations. We're also going to move on to logarithmic equations. What's a logarithmic equation? It's an equation with one or more logarithms. It's an equation with one or more logarithms. How do we solve these? Well, we need to get the logarithm out. So let's say we have log of 4x minus 3 is equal to 2. We need to get this logarithm to the other side. Remember, this is log base 10 of 4x minus 3. So we can move the base 10 over to the other side as the base of the exponent. We'd get 4x minus 3 is equal to 10 squared, or 100. So we get 4x minus 3 is equal to 100. That would tell us 4x is equal to 103. And then divide that by 4, we get x is equal to 103 over 4. Or put that into your calculator, you'd get an answer of 25.75. Now you all try this next one. What is log of 3x minus 2 is equal to negative 1? What's the value for x? For this one, we do the same thing. This is log base 10 of 3 minus 2x. So this becomes 3 minus 2x is equal to 10 to the negative 1. We take the base of our logarithm and make it the base of our exponent. Now 10 to the negative 1, if we have a negative exponent, we flip it, so this is the same thing as 1 over 10, or 0.1. So we have 3 minus 2x is equal to 0.1. How do we solve this? Well, we have a positive 3. We're going to subtract it over. We get negative 2x is equal to 0.1 minus 3, or negative 2.9. And then we're going to divide that by negative 2 to get x is equal to 1.45. So when dealing with the logarithm, all we need to do is take the base and move it over to the other side as the base of the exponent. Now we can also do this with slightly more difficult problems. Something like log of x minus 3 plus log of 2 is equal to 2. Now we're going to need to combine these logarithms before we do anything. These are two logarithms that are added together, meaning that we can multiply the insides together. Log of 2 times x minus 3 is equal to 2. Now remember the common log is log base 10, so we're going to move that over to the other side, and we get 2 to the x minus 3 is equal to 10 squared. Right, we take our base, move it over to be the base of the other side. And from here we just solve. We have 2 times x minus 3 is equal to 100. Divide by 2, then add 3, you get x is equal to 53. Okay. What about if we have 3 log of x is equal to 3? If we have 3 log of x is equal to 3, we could move this 3 into the equation, or we can try to separate it, right? This is 3 times log of x, so we can divide everything by 3 to get rid of this. Just so happens that also gets rid of it on the other side. We're left with log of x is equal to 1. And if log of x is equal to 1, this is log base 10 of x, that means that x is equal to 10 to the 1, or 10. Okay. What about this last one? For this we have log of x minus 3 plus log of x is equal to 1. How would we combine our logarithms together? What would it become? They're added together, so we need to multiply these, or this is going to become log of x times x minus 3 is equal to 1. Move the logarithm over to the other side. Remember, this is base 10, so it becomes the base of our exponent, and we have x times x minus 3 is equal to 10. Or this is the same thing as x squared minus 3x is equal to 10, or x squared minus 3x is minus 10 is equal to 0. How do we solve for this? Well, we're going to factor. Right? What factors of negative 10 add up to be negative 3? It's going to be negative 5 and 2. So we have x minus 5 times x minus 2 is equal to 0. Or our two solutions are x is equal to 5 and x is equal to 2. We're not done with this one, however. We need to check for extraneous solutions. And we're going to need to do this anytime we're dealing with logarithms. Check for extraneous solutions. When we do, let's substitute in 5. We get log of 5 minus 3 plus log of 5 is equal to 1. That shouldn't be an issue. But what about x is equal to 2? We get log of 2 minus 3, or log of negative 1. And that sets off alarm bells in our head, because you can't take the logarithm of negative values. 10 raised to what power gives you a negative value? The answer is nothing. So x is equal to 2 will be extraneous. And folks, that's all there is for this lesson. We're just learning how to solve logarithmic and exponential equations.